live. Oh shit. Maybe I'll drop it down to 20. So I just added a noise filter because I'm outside and there's music playing and I don't want to get muted. So we're gonna see how that audio sounds. But okay, what are we doing? Well, first off, I downloaded this very cool theorem prover and I found this guy's repository. All right, well, let's stay focused. All right, but that's for later. Oh man, I'm clipping. All right. I'd say let's make it 15, maybe 17. Gosh, audio is so annoying, but I don't want to use one of those things that like auto adjust the gain because those are just too messy. All right. So it seems like we have a good bit rate and we're getting started. All right. All right, so what are we doing? Well, let's start by opening the S code. Open our correct window. Okay. Okay, so we have some pretty exciting news, and that is, well, first off, let me just show you what this is. I wonder if that's not what I wanted. Okay. I'm sure this is not great for content, but I need to be able to see the screen. Okay, so what is this? We're building a computer algebra system, so I can run this program. Okay, cool. So it started up and it's loaded some files. So what can I do? I can set x to 1, I can type in x, but then I can say set my function, and it's going to take a single argument, and that argument can be anything, and it's going to return I. So that's not very cool. Oop. So now I can say my function. If I do it with no arguments, it returns itself. But if I give it x or y, no matter what, based on our pattern matching language, this pattern matches any argument that I could possibly give here. Okay, so that's pretty cool. You can use this to write many things. We can go to our startup and we can see some examples of one cool thing, nest list fx10. And now we have a list of x being repeatedly applied to 1 over and over again. That's pretty cool. How can we use this to do cool things like simulate cellular automata? Well, good thing is I wrote this code. So first off, we're going to define a rule, or we're going to find a function. And this should probably be set D. And basically what it does is it takes a list that has 3 elements in it. And then it returns XOR of the first one with the OR of the first 2. And by the way, we can see in startup that we have our rules for Boolean operators. And we don't have all of them, but we have some of them. And this is just so that we can do stuff like or, false, true, and get true. And so that's pretty cool. And then one thing that I want to show is that we have this function called head, and it returns basically the type of whatever is the, so I could say head of 1, and we get an integer. So we get the type of it. Well, it's really cool because bool is not something that's built into our language. The only atoms that are built into our language are sim, int, stir, and real. Then we have a compound type, where if I give another parentheses here, let's say we put something in it. The head of some compound expression is just the first element. So that's just sort of how the language works. So now I can do stuff like I can take this whole line and just copy it into here, and now I could say rule 30 of list false, true, false. And now we see that whatever cell below that is true. And so if I were to go to here and say we can indeed see that if we have a single black cell and two white cells, so false, true, false, then we should be false, or true. And that is exactly what we get. So then what can we do here? So I started to write some pretty bad code, honestly. Basically, I have a function that just joins, so we have this function join that takes three lists. So we can see that here with the argument here, here, and then here. And so basically, this second argument to blank says, what is the head? This pattern will only match if this head is equal to the head of what we're trying to match. So and we can test this out by using the match q function, which q is just an identifier to say that it returns a bool. So if I do match q of false true, it's going to return false. If I say false blank, we get true. But now if I say false int, it returns false. But if I say false sim, it returns true. So the head of false is sim, so then this matches. So similarly, if we have a list ABC, then we can test that. We can test that that blank list matches some list. But if I change this to something else, then we get false. So we're giving it a list, and then we're giving it a value. And basically, we're padding that value onto either side of it. And the reason for that is that if we whatever, I know how to do this. We're gonna plot the simulation of this with zeros, infinite number of zeros, 5 times. Oop, and I forgot this. And so basically, we need to pad zeros on the ends of this, because otherwise we end up growing inward because we don't know what is on the side of it. So the way that this works is if I do, and let's copy this into here. We can do add val of this 1, 2, 3, and we want to pad it with 3. Then we get 3s on the end of it. So this is just a helper function. I'm pretty sure the way that you would do this in Mathematica is much more. You definitely wouldn't need to define this function, and I'm sure internally they don't. So then I define this function called partition 3. And basically what this does is it gives me a list of lists where each of the sublists is basically the index I plus 1, and I plus 2. So let's copy that in and I'll show you what it does. So let's say we have a table of, or let's say we have set x's to range, oops. I need to do that. Range 20. Okay, so now we have the numbers from 1 to 20. Where were we? We were in systems. Oops. Systems. Okay, so I can do this. And we want tab completion, but that's later. Okay, it only takes one argument. And so now we have the list 1, 2, 3, 2, 3, 4, 3, 4, 5. And there is a real partition function that is much more general, but I haven't implemented it yet. But it allows you to do very nice things. Anyways, So then basically this gives us the sublist that we want to apply. And one function that I should note that's built in is map f to x's. Now we have f of 1, f of 2, all the way up to f of 20. So this is how we map a function onto a list. Or, yeah. Okay. I wonder if that works, actually. Oh, it does. Let's see if that works for us. Oh, okay. So we found a bug. It's not supposed to return a list. Cool, hold on. We found a bug. In map. Um, all right, so let's see if that works again. Okay, cool. So we fixed the bug. Yeah, we shouldn't have hard case to list. All right, let's go back to systems. We're going to copy all this back in. Okay, now here's a function that's just a helper, and all it does is it takes one of those partitioned lists, and it takes one of those partition lists, adds false to the ends of it, or it takes a list, it adds the false value to it, it partitions it, then it maps rule 30 onto each of the values of the partition. And so we can see what that looks like. So we're gonna do, or yeah, I can do this. Okay, so now we have u0, which is our initial condition, is equal to this big long list. And what we did is we made it 0 so it's easier to read. And at some point where we need to add list mutation so that we can, because I can do table of 0, 20, and that's fine. But the problem is, this could be 200. We have a whole bunch of numbers. But the problem is that we don't have any way to modify one of them. So we need list mutation. But anyways, so we have this big long list, and then we replace 0 with false, and then we replace all the ones with true. So here we do this. Then what we do is we call foo, nesting it 20 times. So then we can do this. It takes a sec. And now if we look at part ls1, then we look at the second one, and what we could do is we could do this. Replace all, list, rule, false to 0, rule, true to 1. So now we can do this again. And we need to add one more guy here. Okay, so now we can do the part again. So we do part, okay, then we look at part 2, we look at part 3. And so we can see here that we are correctly simulating the rule 30. So this is our first really cool thing I feel like that we can do in, we need to clean it up. But one thing that I adjusted that I think is valid for me to do, but before I had a really, in nestless, which is a built-in function just because it was easy to implement without, anyways, the problem that was really annoying is that I wasn't actually evaluating. So, we would make a list, we'd put x in it, then we put f of x in it, then we put f of x in it, and we keep going. But the problem is we built up this list and then evaluated it. But what we want to do for these iterated maps is that we want to evaluate f of x eagerly here, so that when we look at the last result, then we can just use that, and it's a sort of a form of memoization. So that sped up this simulation of the cellular automata by a lot. Like before, it was insanely slow. I mean, it was like, yeah, you can see why. It was just super slow. So I think that this is valid, but this is a change that worried me a little bit because, but I don't know. I want to combine all my non-core crates. Ooh, that's a tough one. I've always liked Toolkit. I like Kit. Toolbox is pretty good. I think Utils is kind of lame. Utils feels like it's not official. You know? Okay. So what do we need to do here? Yeah, so anyways, now we can actually get to, it's Kit right now. I like Kit. What's the full name of it? I want to combine all my non-core crate. See, does this reach? Not really. Spire. Let's see, let me look up Spire. Yeah, like a church spire. Right, oh, because of tower? Yeah, it's probably because you use tower, right? That's cool. I can see that. Let me ask GPT. Building a web scraping framework in Rust that uses the tower framework, and trying to find names. Trying to build an ethical web scrape. Trying to find names for it. Currently calling it Spire because Spire is a, let's see. Is a noble initiative, bro. This guy's so funny. Naming your project can be fun but challenging. Is part of the skyscrapers. Sentinel? Pillar sounds lame. Sentinel sounds cooler than Pillar. I think Spire's good. Obelisk? Citadel? I wouldn't call it Citadel. Obelisk is not the craziest. I mean, Obelisk is a little much, I feel like, but it's kind of cool. Dude, I love naming things. Naming is such a tough problem. Sound like they're taken. I believe it. Well, okay, like what is web scraping? web scraping is like going out and like I imagine like you're a ship in like rough waters. You know what I mean? And yeah, but yeah, like web scraping. I imagine you're like on a ship and you're visiting all these like coastal towns, and some of them could be filled with marauders and stuff. Um, Spire's pretty good. I'm still trying to think if there's another core name that because Spire doesn't make me think of web scraping. Spire makes me think of like Spire doesn't make me think it's a web scraping framework. So I'm trying to think maybe there's something. Do you know what I mean? Like, I still think Spire is a good name just because of the tower dependency. But what did you say? What is the thing about the skyscraper? Hmm. Yeah, no, that's true. No, I'm just messing around. I'm just thinking about it. Okay, imagine what's a good name if we think of web scraping like journeying out into the great expanse of the web. Voyager? Dude, I kinda like Voyager. Expanse Scraper is the worst name I've ever heard. Expedition's not a bad name. I wish they sold coffee here. Such a shame that they don't. I think Spire's pretty good, but I don't know what other like Dash Voyager taking. Oh really? That's so funny. That's so funny. Oh, it's a pretty big repo. Someone had the same idea as me. That's wild. Kick W E. Oh, this guy! I know this guy. That's crazy. Yeah, he wrote the differential equation package. This package is sweet. That's so cool. It's funny how a few people build all the cool like. Damn. Let's see what other names did I come up with. These are all trash. Spire's pretty good. I feel like Spire's nice because it's short. It's dead. Yeah. Spire. I feel like Spire is pretty good. Um. Okay, so what are we doing today, though? Today we are improving the pattern matcher to handle a couple of things. Uh, Alternatives. Oh, dude. By the way, I did something where I. Yeah, I know. The best stuff in the ecosystem is definitely built by a small. I mean, it's a power law thing. Like, there's just some extremely talented developers. Oh shoot! Hold on. Um, what was I gonna say? But yeah, I found something where I wanted to use uh, your package actually. So down here in these doc pages, there's this history, and it says what version these things were introduced. And I found this super cool package called DLM, and all it is it's a minimal HTTP downloader manager that works just fine. But it's actually amazing because you just give it a path to a bunch of URLs, in a text file, and it just downloads them super fast. And if you like if it like 404s or something, then it doesn't download anything. So you get this super clean thing. So I downloaded every single page of the docs, all 7,000 functions or whatever. And now I have this thing. Let's see, where did I put it? It's probably in DLM. Or no, the CSV is probably in WL scraper. Oh shoot. Um Anyway, so now I have this CSV and I have every function and what version it was introduced. And that is so nice. So I had to do a bit of web scraping recently. But this package worked out way better than it, because I've always wanted to build just a nice download manager. And this one worked out just so well. Okay, so we want alternatives, then we want pattern test. And I feel like these are the first two that we want to add to the pattern matcher. So I feel like I should just start on so let's get this. Let's go to the full form of this. Oh. Yeah. Alternatives A and B. So how does replace all work? Okay, cool. So yeah, we're calling match queue of oh, this is yeah, but here that's still going to be true, but expert. Oh yeah, so here we check the head. Oh, I see. I'm just zoomed in too much. We can clean that up a little bit. But yeah, so here if we get a list, then we iterate the list recursing. So that's okay. So then we end up calling my match on each of them with the original rules. So yeah, so in here, we probably want to say if I don't think that this will work. So everything should still pass. But if we do match Q, you know, A, B, C. But what's another case? Because I feel like this is not all that we have to do. A, B, C. And then it's rule alternatives A, B to X. And then this needs to be lowercase. Yeah. So now we're in the case where we need it. Okay, so what? Oh yeah, we should try that. Hmm. Uh. Damn. Right. I know why though. But that should return true because we get F and F. Okay. Then we iterate PS. What are PS? The elements of the pattern. And we skip one. That's right. Push that we add the new position. I think we just need to add. I think we just need to add. Is that it? No. Is it supposed to be X? I don't think it's supposed to be X. Maybe I should. Oh yeah, optional. I wanted optional because. Wait, what? Is that a? That's a part number. All right. Well, let's I guess try to stay focused because alternatives would be good. Alternatives is getting my head a little messed up. Okay. What's an example of alternatives that use a sequence pattern? This is 8. Huh. Uh. Hmm. Oh, well, okay. Oh, shit. I'm just trying to think about what happens when it's sequence. Man, they got rid of the cornhole here. They used to have cornholes. Alright, so let's start to add debug info. I think we need to add a fast path for whatever. I'm not getting distracted by that shit. It's not any of my concern. Okay. Like, why does it go through so many of these? Yeah, it loops over all the attributes. That's just a horrible way to define how to find the attributes for a symbol. I feel like we should just do a manual lookup into the hash map, but whatever. So we have this. Now we want to do match q of g, or actually no, we just want to call g of a. I think it might be just a matter of oh yeah, that's true. I think we did it. No. It's probably because we need to move this one out. This one's out. See, we call attributes so much. Where does the real match actually even fucking begin? Here. So this is the only part that. So we get G, G. No, but if we've already looked at the heads, then this is bullshit. But how does alternatives work with? What's a good case? Yeah, we have G of A, B, and then G of A or double blank, like that. I think that's right. So we do then we have G of none of these cases use oh what? What? The sequence. I don't know. It seems like they were not right about that. Ugh. Hmm. Damn. Or you could call shouldn't that do it? Or oh, but it's not P, it's you wanna replace that with um uh so you copy it and you say P copy 1 is equal to, then you give it a P copy. Wait, is this right? Wait, that's not even right. Because what you want is you want yeah, we do this every single evaluation run. The number of times that we go through the pattern matcher doing I will open an issue for that because that's just total bullshit. Is too damn high. Because this is bothering the hell out of me. All right, let's see if that cleans it up. Oh, lol. All right, that's fine. That's fine. Ugh. No. Stop, bro. So that's good. Hmm? Why didn't this return true, though? Well, okay, we don't even hit this branch. Okay, now we're in an argument of a list. Oh wait, actually, so wait. I want to try this though. So we have Q alternatives Z blank. So this works. Evidently not. Wait, I don't understand. Oh, yeah. No, this is true. This is true. This is if the head is it, then all the rest are going to be the alternatives. So that's fine. Uh-oh. And then, no, yeah, right. So we had it right the first time. Where this is just going to be P. Okay, so we had that right. That's fine. Oh, nice. Okay, so now what we have is we have A matching alt A B or to B. So then we have MQB alt AB, and that's true. But I feel like this one might be wrong. So this is the case where the head is not alternative. So we have F, B, F. Right. So I feel like here is the case where we want to recreate the whole thing because X here is still FAB or FB. That's why we get these comparisons. Okay, so so how does this happen? Okay, so we don't find a match. Oops. Okay, so we looked at the head, so now we're doing MQ of FB alt or F of alt AB. So yeah, so here Here we check that. So we get f of f. Now we're trying to match b with alt ab. I feel like we don't even need this though. Yeah, this is stupid. So why does that fail? Oh. Okay, so I can think of a way to do that. We can just append to the position map. And we just say that alternatives goes to whichever one it is. So we want to insert into the position map. So here, so we don't want to do it in here, that's for sure, I think. But can we get to all right. But you need a way to report. So maybe you do insert it here, because the position here is the position of the alternative. So I feel like you could do pos map dot insert pos, and then what? Oh, I don't know. But that I don't know if that's valid. But I feel all right. Well, let's see if that does kind of what I wanted it to do. Does our print? All of these things are crazy. Maybe we should fix that. We need to remove it, right? Because if we do this, oh, yeah. Yeah. So oh geez. That's a tough one. That's a tough one because God. Regardless, I think that this should be fine. We do. So that works. Yeah, it's kind of an abuse of Okay, so you have FAB, and you're matching with FA or blanks, X of blank C. So that's so it could be that what you could do is something like up here before you even you know um uh or wait, we don't even need to do this. We could just do then what you do is you this is probably right, honestly. I'm gonna try this. So I feel like this is makes some sense. That's cute. Or wait, we can just do this. First, let's say um. So then, why does the nested case here fail? It's just because we're not rebuilding properly. That's what my guess is. I don't think that this is the right approach because this is like this, but I think it might solve that. Mm. Right. You need to have rules to tell you how to do this. So okay, so let's say that you have another position map that predates the first position map. which tells you which alternatives to pick. So wait, but no, but this doesn't do what I was hoping. Wait, can we go back down? Okay. If the head is alternatives. No, yeah, I had it right. That's definitely wrong. Yeah. Okay, so to clarify the issue, so we're gonna go back here because this is somewhat working. Oh, whatever. The point is that when we do this loop, well, let's give an example. That just returns true. That's fine because it's all literals. But let's right. That still hits the fast path. Am I inserting anywhere? How the hell did that work? Okay, but now let's say. Oh shit. Wait, what's the case that doesn't work? Wait, that does like a lot of what we want. I do not. Um, this is just insane. What causes that? We do need to invoke the pattern matcher for this, though. Is that true? There's gotta be a... Well, okay, I guess the solution is to just not... Yeah, because this is how we're getting the attributes of, or the down values of attributes. Then we get the actual attributes. It's got to be issue 16. Why is this empty? These are my issues. I guess that's a sign. All right, okay, all right, fine. So I don't want to fix that. I just want to look into it. Oh, actually, it's interesting because what we do is we pretend that we're at the position of the alternative. So that's actually kind of smart. So that's why this works. But then this doesn't work for the same reason. Right? Oh, wait. No, wait, this does work. Because then when we call this, we're still pretending that this is at the position of that. So then what is the case that fails? The case that fails is... Why does that fit? Do we insert? Okay, wait. We want to make a test set for this. Wait, why did that get disabled? What? Oh, yeah, because we need to do... We need nest. So we need to do this. I think that's fine. Mute context. Okay, cool. So I think that's all we need to do, and now this test will pass. Okay, cool. Oof, that was scary. Okay. Can we look at the attributes for alternatives? Okay, yeah, it's nothing. I think we can... I think we can keep this. So what are our test cases? We want to actually use this thing. But here, it's just going to be a vec. There you go. Okay, so what are our test cases? Okay, so we're just going to write them as one string. We're going to say match Q, A, alternatives A, B. So that's our first one. And then what we want to do is for in cases. I don't even know if we need the context here, but that's fine. Let's see. Okay. Oh, I guess we do want this. Okay. Oh shit. Okay, then we want. Oh. Then we want F And this is the one that fails right now. So we do this, so we get a failure. Oh, really? Oh, did that fix it, actually? That's kind of crazy. All right, so, okay, so wait, so what are our other cases? Let's look through our history. I'm so glad I have this long-ass history. All right, so this is a good one. That's cool. What other cases do we have? This one. Let's try to run some of these out. Yeah. Well, so that's that one we test. So let's see if we can do it with set. So we do set D H alternatives A B P. And we do H of A, we get P, we get C, we get H of C. So that's cool. This is a good one to test. Set L, list of x power x2 power x3 and power y2. So that's our list. So that's fine. Now we want to do replace all L rule alternatives x power x blank. And this goes to Q. Wow. Hey, this kind of works, bro. Did we do it? What is this doing? Oh, this is the matcher trying to find all these rules that we've been. Yeah. That's pretty, let's see. What else do we have? This one works, I think. I think we just tested this. I honestly don't know how this works. Okay, but let's add another one for pattern x's. And add one here. I just make sure that that also. I mean, I don't expect it to do anything weird, so that's good. What other cases do they even show? That'd be pretty cool if we got this to work. I think we've already tested this. Cool. So that, I mean, that does what we want it to do. Wow, that's a pretty small change to improve the pattern matcher like that. Too bad that there's no good syntax. So what had to be changed here? This is honestly suspicious to me. Cool. All right, and then this didn't. Man, that's such an easy fix. All you do is, if you look, see at the head that there's a alternative, then you iterate them, and if you find one, then you just fake your position. I think we're good, guys. I think we did it. I'm gonna try another case. Yeah. Nah, man, I feel like I can't break it. Cool. I'm gonna add that one. I don't think we don't have any negative tests, so maybe that's a problem. Can we try this? Just a false. I mean, I feel like I'm just testing cases that I've already tested before. But I'm very concerned that I do anything to the pattern matcher because we really don't want any regressions. But I just don't see anything that's wrong. All right, cool. I think we want to introduce an option system. Well, should we do pattern tests first? Pattern tests might be a good idea. Wait, oh, I went too far. Free Q is such such a good. I feel like some of these. Whoa, there's a bug? How could there possibly be a bug? Terrible. Pattern test is definitely easier to write than. Okay, wait. Let me commit my changes. What did I make it? Wait. Okay, yeah. Let's just go through all of this. Okay, so bunch of stuff, mainly alternative support. And then for my aliases, I could add. It's nice. Okay, let's go back to main. Disable index prints in part was noisy in partition. But I think that we want them, so maybe. Okay, seems like we're back. Cool. What did we do here? Oh yeah, evaluating the intermediate result in nest list. Avoids a big perf improvement in simulating rule 30. Okay, what else did we do? Oh yeah, implement join. Why did we do this in? Yeah, no. We have to do it in the kernel because the pattern matcher is not strong enough. Okay. Basic timing function. I think it's kind of. Oh, actually. Wait, this is a good way to test whether or not they intermediately evaluate. Oh, is it? Actually, no, it's not. No, because was I doing nest list or range? I'm not sure. But anyways, it's documented. Add a note about 16. Because you don't need to invoke the whole pattern matcher. You do need to iterate the down values of adders if that's how we're gonna have it work. I guess I don't know how. I'll make a note that I don't know how they do it because down values of attributes is empty. Maybe it's okay. Thrill of it, always thinking on the hand. Okay, cool. What else do we do? Oh, yeah. I'm so glad that it was such a simple change. You just lie to the position, and that's such a clever way to do it. I love that. Cool. That's it. Okay. Now we want to do pattern test. Is that what we want to do? I feel like options might be cool. Jolene, Jolene. What? What? The option system is probably pretty difficult. Gives the list of default options assigned to a symbol. Gives the options explicitly specified in a particular expression, such as a graphics object. A particular stream? I don't know what a stream is. Jolene, Jolene, Jolene. What's my audio? My audio seems pretty good. -10 is like, I guess that's where you want to be. I mean, that is super tight. -3 to -1 dB. -3 to -6. Yeah, so I'm a little bit quiet, but whatever. Many built-in functions allow you to give additional arguments that specify options with the rules of the form named rule value. Options F gives the list of rules to be used for the options associated with the function F with no explicit rules. If no explicit rules are given when the function is called. Options always give a list of transformation rules for option names. You can assign a value to option symbol to redefine all the default options. And then you can use set option. Okay. See, but I guarantee that if you do down values of options, you're going to get an empty list. I guarantee it. So they do something clever. Is there even a way to get up values? Yeah, I don't know. So they're not up values, they're not down values. I don't really understand. I don't really understand what it's supposed to be. Well, okay. Let's keep reading about options. The reason why that we're doing options, by the way, is that now that we have this, now that we have this, we want to make an SVG or something. I'm just curious. But do we really want to depend on GTK? I feel like no. I feel like this is a whole. Let's see. Are there examples in here? I feel like we want Cairo examples. Oh, and of course, there's no examples. I mean, Rust in general is way better at examples than other places, but That's a pretty high minimum version. Okay, well, let's keep reading. So clearly, I don't know if it's clear, but I feel like options and optional oh, that's nice. Ternary form of that? I kind of like that. It lowers to the same thing. What's the difference between that and an own value? When it gets evaluated, I guess. Directly integrated into the What are the attributes on rule delayed? I think it's just a matter of hold rest. All right, maybe we should do something kind of like clickbaity, something kind of fun. But the thing is, we don't want. Dude, I love that they just have example data. Spiky. Oh, this is so cool. Gives you a data set of all the information. It's fucking rad, man. Wait, but why does it have a height? Maybe I should just do it. What was it again? It was like cloud object. From cloud to It's a cloud object or something. I think it was cloud object. Yeah. So wait, where's our array plug? I just want to look at it. What? I think I have to do like cloud export. What? Wait. Cool. So it's here. Dot rust, right? Dot rust dev cas3. Let's put it here for. Oh. See, I don't know anything about the standard. What is it? It embeds the base64 PNG into it? So is it not a... Because I would assume that it's like a... I mean, this is where all the data is, this base64 encoded thing. What do these even mean? Let it go. This is what I say. Alright. I don't want to do it in here. I want to make a new repo or a new thing. Can I have graphics stuff? There's some 6-hole bullshit in here. How do we do this? What is glib? Graphics lib? Oh, good. These big projects always have this nonsense in it. Cool. Is that the whole thing? All right, let's see. Why do we need Cairo and cairo.rs? What's the difference? What version are we using? What? Because this is just the wrong repo. That's bogus, dude. Take this shit down, bro. Yes, dude. Take it down. Why can't I? Oh, yes, bro. Take that shit down. What does he work on? Little foot. Yeah, bro. Map to image. Is that what we want? Wait, hold on. Wait, I want to save it to a. Do you need to unwrap? You need to do surface dot finish. They didn't say anything about that. What? What does data do? Take data, image surface data. What the hell is image surface data? You get the surface, you get the slice. Should we just get the slice? Maybe we should just do that. Dot slice. Ugh. I need to give it a. Come on. Save. Cairo rs CG. Right. Is there any example? Somehow they just fail to have any examples. Ridiculous. I just don't understand why they do this to us, man. I mean, this is the kind of code that's just like so annoying. Why can't it just work? Can I just call it dot into? The hell? Should we do that? Where do we do it? We do it here, or we do it on the into? Okay, I don't know. That's bogus. What is the type? SVG servers. I see. All right, let's see if this works. Oh wait, hold on. Oh hey, they have a PostScript thing too. Expected an option, bro. What? Oh, cool. Is there a viewer? Can I get an SVG viewer? All right, let's do this. Oh, nice. Damn. Hold on. Let's see what happens if we just copy this to source. Does that work? I don't know what I just did. Okay, so how do we just view the SVG? It's like so whack. Oh wait, hold on, I know what's doing. You go like this. I'm gonna add. I'm gonna add this folder to here. So source is on the other side. So then we go to cas3. Why did I save this to cas3? Wait, that's just not right. Graphic stuff. Oh, nice. Okay, so wait, we should be able to just open. Oh, cool. Nice. I want to look at the actual contents of this now. Okay, so now Alright, so what do we want to do now? What does show page do? Alright, cool. Okay, so what we're doing is we're now going to write some function that's it takes expr so this has head export and it obviously always returns an expr. Then well, we don't even need to do that because we're never going to enter this. So then what do we need to do? We need to turn this into, so this, okay. So this is good. And then we can start to mess around with options. This is great. And you feedback into a See, I wonder how they do this color stuff. Because if you just give a list of length 3, then it interprets this as pixels. So maybe there should be like a pre-processing step that just unwraps it. I don't know. This is like not that interesting. I just want to look at the picture. All right, fine. Let's just do this shit. I don't care. Uh, all right, so for now we can just expand it into 3 tuples. I'm good with that. We're picking a function that returns the back of these colored tuples, or that takes a and a file. Let's see, what else do we need? Oh yeah, and the scale. And the size is, what is the size? All right, that should be fine. We're getting close, guys. We're getting close. I'm concerned about build times. I feel like build times are gonna get worse. I hate these fucking dependencies. I'm blinded by the light. All right, so what do we need to do? All right, we're gonna do this. Add rs dash svg. Do we want SVGs or PNGs? All right, let's just where should we put this? What happened? Okay, cool. So now, For now, let's not put it in there. For now. What is the standard form here? Oh, and it probably has attributes. What are the, maybe it's empty? It's fine. Okay. There's probably worse, but it's so bad. Right, we want something that unpacks list of list into its underline. I'm just gonna ask because I feel like this one's easy. Oh. Um. what? What? You see a list and make a hash.
That was very helpful.
This is just so wrong. Dude, this is bogus. Yeah, because bro, this is like whack. Okay, simple. Let's assume that we have a list of list of list of. Oh, but the. Alright, we'll just write it ourselves. Well, I'm being an idiot. Ooh, let's just do the matrix case. Okay. Damn. It's so annoying. Unpack. To back of. What do we want it to take? Alright, let's just make it take F16. Alright, let's do this. Let's just make sure it's the same type. So we've already done the replacement. Okay, so we have don't we want to iterate? Okay, so what we have is we have list of list. So wait, do we have else? Yeah, okay, so what we want to do list rule 0 to list of 0, 0, 0. And we actually want these to be reals. I want to save this code. All right, see? What? Is that true? Wow, the printing of that is super annoying. We need to fix that. Okay, but those are reals. But I want to change the parser real quick. One or more. Real needs a dot, but what do we need? 0 or more? The fuck? Okay. Why does that panic, dude? What? Oh. What? Okay. Well, let's see what happens. What happens if I call? This isn't evaluate. I think we want to return this. Oh shit. Did theirs throw a little error? It didn't. Okay, so what we doing, fam? So we fixed that parser thing. Now we need to run all this again. We want to set pixels. Cool. So those are our pixels. Oh, wait, no, this should work, right? Why didn't that work? Or wait, no, sorry. We want to call nice. Okay. So what do we want to do? Yeah, did I call that? Um, so what is L? So L is but okay, wait. So this is going to be the rows. So now we have a list of lists. Hold on, I just want to print this out. Okay, we have a list of lists. This is e's. Or x. Then we go into here, and then we have e, which is this. And then in here, we have an L, which is just a list of names. Pixel values. What did it say? Bro, Copilot is okay. Do we want we want real? Oh wait. So first off, we're gonna comment this out, and we're just gonna print line PS. What? Ugh, it's gonna print out like crazy. Okay, so then the function run, not in run, in main. Wait, we need to do. No, we need to do this way before then. I think this needs to be a first thing. But then we want to do this. I'm going to comment this out. We want to run then we want to run so now in our context we have PS. So we want to evaluate, so we want to call, it's called let m equal unpack mat on let equal context without parse new context, and then all we need to do is I think that's it. Cool. We definitely want to benchmark. Okay. This is getting slow, bruh. Okay, so Bro, why is it writing all this bullshit out? Okay. That seems pretty good. That's pretty nice. So now in sure. Sure. Then we want to call what is what do we want to do? We want to call color this thing. Bro, what is the function called? Oh, but we. Oh, did this? Oh, that's nice. Cool. Get the value out. Okay. Okay, cool. So now we want to call export, and then we give it the file name. And then we call PS. Oh shoot, strings can't have dots? Okay, we have to update the parser. Here are the blocks. We have a problem string. We need to able to include dots. What do we want to do? We want to. How does it print when we have What does a single at do? Dude, I've been using this for so long and I still don't know this syntax. So what is the difference between prefix and apply? Yeah. Okay. What we up to? We want to make the strings more capable. Wait, I should add the. See you later. I wonder how we can just make it arbitrary UTF-8. Are there built-in rules? Should we test for me? Wait, what? I don't even know what. What is NRT? Oh. I don't like that. We'll need to do string escaping another time. Wait. So what's wrong? Oh, the comma. Bro, I'm actually dumb as hell. Oh, wait. No. The hell? That's all Gucci. Oh wait, I think I know why. I think we want what? Bro, what is going on? This is getting really annoying. Something feels so laggy. Wait, what? Oh, bruh. This is just not interesting, man. Oh, oh. Yeah, we're good. I think I figured it out. Just need to do this in the other places. Oh, let's go. Whoa. We did it, guys. We fucking did it. We flipped the thing though. We fucking did it. Okay, I wonder why it looks like that. That's so crazy. We got the grid though. I wonder how it does that. Oh, that's so sick. Let's go, guys. First CA in cas3. How's my volume? Oh, good. It's like, I feel maybe I could bump it up to 20. It's a dangerous game because I hate when it. Whatever. That is sweet. The problem is we flipped it. That's okay. Let's just switch it in here. There we go, guys. That is so nice. I think we can do. Wait, let's say random. This is not gonna work, right? Um. This is just general nonsense. They don't know. I'm down to test that. I don't know if that's right. Right, you would see more. Is the question? Is the point? You would see 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. Cool. Okay, what are these stupid printing things? I think what I want to do is random, so I could simulate random initial conditions. Whoa, why is this so slow? I want to delete it. That's so cool. It's a big ass file. I'm gonna add this to the README. I'm so not happy with the new dependencies, but like, kind of cool. Okay, well, pretty cool. Sad days. I wonder if this works. Fuck. Okay, so this is just a list of lists. I'm gonna try to see if cloud export of this works. Oh, this returns a. What is that? I think that's just an image. What the hell is that thing? But there's no. Oh wow, that's actually kind of crazy. It saves. That's so interesting. It saves an SVG of the expression. That's kind of crazy, huh? Options would be very cool. There's so many options for graphics. It's crazy. What happens if I try to do this? Oh wait. Yeah, that's not what I want. I might go get some food now. That's pretty cool. We got a picture. Let's see how long we've been going. 3 hours. That's a good stream. I don't even know. Is this right? This kind of looks wrong. How long is simulated for? Let's try it for the longer. No, I think it's right. These little triangles in the corner. Okay, so now what we want to do is we want to start doing Boolean functions where we can we can take an integer like 25 and turn it into and turn it into and turn it into this. Wow, that is the worst picture ever. I mean, this is all of them possible, right? It's going to be 2 to the 2 to the 3, where the last two numbers are in parentheses. In general, for a Boolean function with n input variables, they can either be true or false. There are two choices, leading to 2 to the n possible input combinations. For 3 input variables, this means there's 8 possible different input combinations. Therefore, for each of the 8 input combinations, there are 2 choices for the output. Yeah, that's how I describe it. Okay, so the hell is that? Kernel maps don't scale, right? I think this is the one that I looked at. Oh, this shit is so nice. You can just give it a basis of operators, as long as the operators are complete. Oh, that's so sweet. Oh, what algorithm does it use? Oh, cool. You can provide a method. Those the only two. What? Does it give me a suggestion? The fuck? I don't see any. How is length defined? Am I allowed to just call options on it to see what it is? Um. Menu. P hard, right? always forget this shit. Wait, what's a problem that's... Are we not found? Undecidability is fucking crazy. Every problem in NP reduces to a... What does that even mean? Alright, well, we're going too deep. I might go get some food. I think the answer is just use random choice. Is that a range or is that a I think there's a range. It's the standard iteration. You do this, and you do 5, then you get. Yeah. But I think if you do this. Oh shit. Bro, what? All right. I'm gonna end it. Check it out. You're fucking sick. That's what we did. Did we commit? Let's delete this shit. Did we change the parser at all? Oh. Right change to the parser. So that we don't need. That's what we did. That's what we